All right, let's look at forces in structural frameworks. Forces in structural frameworks. What are the frameworks that we are talking about? We are talking about the cranes, and there are different types of cranes. We are going to look at shear legs and tripods, and there's also something called a direct crane, and I'm not sure if you're going to have enough time to cover it. All right. So this is how the crane would look like. So this is the position of a leg written A. This is the position of the leg C. And there is D there, which is going to be our backstay. We call that one the backstay line. If it's not a backstay, if it's a tripod, this backstay will be the same as the leg. So in other words, this one here will be the same one that is going to be the same length. So it's a backstay, or if it's a tripod, that means we have three legs. Tri meaning three. To be 1, 2, 3 legs equal. All of them will be equal. So, but for now, from what I'm looking at in this particular example that I just showed you here, you can clearly see that this line here, DB, is not the same as AB, neither same as BC. So which means that one is different. It's a backstay, if there is a backstay that's given. So now what is important here is that look at the legs. They form a particular shape there on the ground. They form a triangle. So on the floor, these legs form a triangle on the floor. They form a triangle, guys. So that triangle here, we're going to draw it. That is the base of this that is the base triangle there. As you can see, those legs, they form a triangle. We are going to draw that triangle. That triangle can either be an isosceles triangle, a scalene. No, it cannot be a scalene, but it can be an isosceles triangle or an equilateral triangle. So two sides must be equal, or all sides must be equal, meaning three sides are equal. If these sides, all of them are not equal, it's a different diagram that you're going to draw compared to the ones that I'm going to show you right now. So we want this triangle to be either an isosceles triangle, meaning two sides are equal, or an equilateral triangle, meaning all three sides are equal. Then we can draw according to the method I'm going to show you right now. So we are going to start with a tripod, meaning three legs. As you can see here, a tripod with three equal legs. Three equal legs, and the base triangle, remember the base triangle is the one that I showed you, the one in red, and the base triangle being an isosceles or an equilateral triangle. So this is, if you find these three things, if you find these three conditions on your question, then you know that we are dealing with this type of a diagram. All right, now how do we draw this diagram before we go onto this? So here at the bottom is going to be your top view. And then this line here is going to be your side view. So we are now people who did mechanical, or in fact, this is mechanical subject, you will understand what we are talking about. For example, here, you can see here, this is a side view. This one is a side view, as you can see. And then also here, we've got a side view, more like a front view if you're looking at it like this. But what are you going to see if you look from the top? That is what we are talking about when we talk of the top view and the side view, right? Right. So the top view is going to clearly show us the base triangle. The top view is going to show us a base triangle. So let's go back to our top view. So on our top view, we are going to have a triangle formed by the legs. Here's the triangle that is formed by the legs. This one here, this triangle that you see here. Here, we're going to draw it here. So if it's an isosceles triangle, meaning this line will be equal to that line, and this one will only have its own value. And then from the legs, what do we draw? So this one is a base triangle. This one is a base triangle. And then where the legs are, you can see this is the leg and this is the leg representing. Let me erase everything here. So it's AC. I'm just going to write it the way this example is. Meaning here, this will be your A and this will be your C. which means this one would be D, which would be D. Now on A and on C, you can see that we have got what? These legs which connect to point B. This is not how we're going to label ours, but I want it to make sense with the one that is there, which means now in red, I'm now drawing the legs. Leg 1, leg 2, they are connecting to point what? B. So this is what you're going to see when you are looking at it from the top view. When you look at this thing from here, you're going to see the base triangle, and then these two legs spreading to the point of what? B. There we go. This is how we're going to draw it. So this is leg, and this is leg. Now, once you are done with the side view, then you then project these values upwards like that. You project straight up. So this would be point B. Now, remember, I'm just using this diagram and in the way it's labeled. We are going to label differently when we start to do that question 5 here. So this would be B1. So this one maybe will be C1. This one will be D1. So when we project them upwards, they become like that. Now you put your compass here, and then you put the sharp side here and your pencil here. You open it to the length of CB, and then you make an arc. Then you make an arc with C being the radius. Now I don't have that to show you here, but you just open your compass between C and B, A, C being the sharp point, and then B being the pencil point, and then you make an arc like this. Obviously, your arc would be much, much better than this. Okay? Now, once you have an arc like that, remember now, how many legs do we have? 3 equal legs, meaning we don't have a shear leg. Remember what I said here? I mean, we don't have a backstay. We don't have a backstay, which is that line here, which I call the backstay. We don't have that backstay line. In our case, meaning AB is equal to BC. So this is a shear leg, 3 legs. 1 leg, second leg, third leg. So which means we've drawn these 2, 1 and 2. Now we need to draw the third one. The third one will then be drawn like this. From B, you measure how much it is. To go like that. So this leg is a third leg. 1, 2, 3. So B, so this line from here to here is the same as this one from A to B, as well as this one from there to there. And then you just join these 2 like this. And then here is where the weight is going to be. So a tripod is actually supporting at the center. This one is not a tripod. So if I were to draw a tripod here, do I have something on your textbook? I'm not sure which textbook you're actually using, but a tripod will therefore look more like this. I'm not very good with drawing. Oh my God, let me try something else. So this is the leg sitting down, this is the leg sitting down. They form a triangle, and then this is where your weight is going to be. This is where your weight is going to be at the center. So the tripod is like this. I hope this one makes sense. I hope it makes sense. But this one is the one with a weight which is in front, whereas this one, the weight is in the center, which is the tripod. As you can see here, the tripod here is the weight at the center. All right, then from here we draw our vectors. We draw our vectors. So let's try to draw from this one. You are now going to take your drawing material, and we're going to draw together. Pause the video. I'm just going to be saying a lot of things. All you need to do is to pause the video, and I'm going to use the labeling now that is on the textbook, I hope. So you're going to follow me with step by step. I don't have answers to this. But I'm sure if you go through your previous question papers, you are going to see this. Now, the first thing that we do, let's get our data. The legs of a tripod are each 6 meters long, meaning all legs are 6 meters long. Legs, 6 meters. We need to choose a scale, né? Or it's given. Let me see. Yeah. Yeah, 1:1, which means legs are 6 centimeters. These are the legs. Now, the base, let's look at the base. 2 things we need to find. The base triangle as well as the So the base is AB is equal to AC. AB, AC, I get 5 centimeters because 1 is to 1. And then BC is equal to 6 centimeters. This is my triangle, and you can see that it's an isosceles triangle. Two sides are equal. So the center point, I must now select the center point, and then remember, 2 sides are equal, meaning this side and this side will be equal. Okay, but how do I draw them? I must first start by drawing the value of BC, which is 6. So I'm going to draw 3 here and 3 down, which makes it 6. So this one will be 6 centimeters. I'm going to erase that. So please draw that. Pause the video and then you can continue. So this will be my B. This will be my C. And then somewhere here, I'm going to have point A. So that AB, pardon me. So that AB, like that. So that AB becomes how much there? Becomes 5. And then when I draw also for BA, this is A, it must also be 5 centimeters. Now, remember guys, I don't have to show these lines. I really don't have to show these lines here. I don't have to show these lines. So I just need the point what? The point A. So there's my point A. But you can see that they form a what? They do form the triangle, although we don't have to represent it. They form a triangle. So I'm going to keep erasing as you are working. So once you have this now, the legs, I draw them in red. So the legs are 6 centimeters. So you know that the legs are from here right through up to there. How long? 6 centimeters. And then this one drawn like that, another 6 centimeters. This is the point there. Now, what point is that? That is point O. So that's where we're going to find our point O. Point O. Right. Now, pause the video and do the right thing. Project upwards now. Project upwards. Make sure you're straight. Project upwards. Project upwards. I've got A1, B1, and O1. Yes. Now, let us continue now with this one. Now, when we continue now here, remember what I said, we're going to open our compass between point BO and then draw an arc. Right. Your arc will look much better than mine, please. The arc you're going to draw must look much better than mine. Okay, I tried. And then remember the 6 again. The 6 of a tripod, remember I said the 6 of a tripod, the weight would be at the center if you are having a tripod. The weight would be at the center. And then join this one of that line. So it's AB, that is 6 because it is a leg, 6 centimeters, and this one you just join it between that point and on the top, which is going to be our point O. Which is going to be our point O. Okay, so this one is O1 and O1. That is the perfect O there. Then from there, what do we do? Don't forget, we've got that line of the load. And the load, they said, is 5 kilonewton. And remember, sorry, the load is 30 kilonewton. And 1 centimeter is equal to 5. So 5 divided by 30 to be 5, 10, 15, 20, 25 is 6. So the load is 6 centimeters. Now, this is where the trick begins. This is where the trick begins. I'm gonna erase a lot of things here. Now, let us see. Erase this because we've already done. Now, I need to draw that line of what? Straight down. Guys, remember, the load is straight down. It's like it's a straight down line. Because the load will never be pulled to the left or to the right. It always goes straight down. So this line here of OL, we call it OL, must be 6. But we can't draw it here because if you draw 6 here, it's going to go down like that. In fact, even markers, if I mark your test, I don't like it when you draw it here. So you take this OL line straight as it is, you draw it here on the side. That is the line of OL, but how long is it going to be? 6 centimeters. There we go. OL, 6 centimeters. Now, what you want to do now is to draw a line parallel to this line here of OB. So in other words, you're basically taking this line of OB exactly as it is, to join it here, parallel. That is what we mean by a parallel line. How then are you going to do that now? This is something that I cannot teach you now. You are mechanical students. You need to know how to draw a line that is going to be exactly parallel to OB. For example, let me just take this one like this. These lines are parallel. In other words, this line, okay, now it's taking everything. Okay, it's taking everything. So here's the line that it is parallel to this one. This line here is parallel to that. So you take that line and then you put it there, like that. Obviously, you must use your ruler, set squares to make sure that the line is like that. Which other line are we going to take? There's the line of AO. I need a line parallel to AO again. I'm going to construct that line, take that line like this. Please take it the right way, guys. Take it the right way. You see now? This is what I have. And where these two lines meet, I'm going to call that point what? M. That's point M. So I've got those lines. Don't forget, my line must still remain there. Right? How you take this line and draw it exactly like that there, I don't know, guys. How we do that, I do not know. Somebody could measure an angle. These two angles must be the same. I don't know. Somebody will put set squares and move set squares so that you form that triangle there. But this line here of OM must be the same as that one of OA, and that line of ML must be the same as the line of BO in terms of how it should look. All right. Now, that is OM right there. All right, I'm just going to pause a little bit and then I'm going to continue as to show you how the rest moves. Okay, then from here, but let me go back. Yes. Then from here, you measure that value of ML. You measure that with your ruler, that value of ML. Then you come in and you draw it here. So that should be your M and that would be your L in exactly amount that you got from ML here. All right. Then when you take that ML line, then from there, now what you need to do is this. Again, another parallel lines now. Okay. Right. Here, it's easier for me because I'm just gonna draw lines like this. Oh, it's not straight. I'm just gonna draw. You can see the line I drew it is parallel. Ne? I just wanted this line alone, yes. And then I'm gonna draw a line parallel like that. There. So my line I'm drawing is parallel to BO. And then now I have this line as well. Now that line, I take it, there it is. It's meaning I have a line parallel like that. Okay. So I form a triangle. Now my triangle here, guys, is gonna be a perfect triangle because these two lines are parallel. So it's gonna give me equal amount here and here. Just that this one, I didn't use rulers. So that would be line what? T. Then our diagram is complete. Now our diagram is complete. So now draw a side and a top view. This is what they're looking for to the given scale. Now draw vector diagrams. Now these are the vector diagram 1, vector diagram 2, and determine the force in each leg. Now what is the force on each leg? How many legs do we have? We've got 3 legs. So we are going to say which force is on each leg. Now we've got leg. Let me write this down and try and see if I can move this. Okay, force in each leg. Let me remove this one completely because I don't need it now. I'm just gonna have the force on each leg. So I'm gonna have leg BO. BO is the leg. Leg again is CO, and another leg was AO. So I'm gonna have them like this. I'm gonna have the centimeters, and I'm gonna multiply those centimeters by what? By a by no now which oh these are the legs, but what is the force on BO? Let me do this again. So on BO, here's BO. BO. Now BO is represented by this line here, which means the force on BO, I'm gonna find it on the vector diagram, which is going to be this line here of LT. LT. I'm gonna measure that LT and then multiply it by what? By scale. Now CO, there's CO. And CO is parallel to which line? CO is this line here, which is MT. I'm going to measure MT in centimeters. I'm going to multiply it by scale. Remember, the scale is force, the scale of the force. And the scale of the force is 5. 5. I'm going to multiply it by 5. And then, which is the last line? AO. AO. Now, AO, there's AO, is parallel to which line? AO is parallel to this line here on our vector, which is OM. So I'm going to measure the value of OM and multiply it by what? By scale. That is all that they are looking for. That's all that they are looking for. All right, let's go to the one with a shear leg now. Now, this one here, let me see, this one doesn't have a shear leg. This one has got an overhang. This one can have a shear leg. Now, to draw these vectors, we're going to use the same method of parallel. But this one will differ. The shear leg one will differ in this form. Let me make something here. So in other words, you're gonna have your triangle, and then you're gonna have the point A, and you're gonna have the legs, and then you're gonna join them. The top view doesn't change. Now, what am I drawing? The one with the shear leg, and two legs. Two legs. Now, leg 1, leg 2, we are done with the legs. The next one is now going to be the shear leg, like this one here. This one has a shear leg. This one has a shear leg. There's the shear leg. BD is the shear leg. So when we draw this one, so the top view is like this. Now what changes is how we're gonna draw how we are going to draw the side view. Remember, we've got that value there, B1, A1, maybe let's call it O1. And then you're gonna make an arc. Now the shear leg is longer, so it's not gonna go here, but it's gonna go like this. As you can see here, it went far above the center. Far above the center. So your shear leg will be like that. And once you get that point, then you draw down. Remember that point there is O original. And then where are we going to have our load is going to be there. So when you draw a vector, our load, we always start with it down. And then what do we do? Parallels. There we go. This line is parallel, comes here. This line my apologies. I think this line will come here, and then this line here. Okay, how are we gonna combine this? Just give me a minute. Let me just look at it quickly. Okay, so we are going to draw like this. Yes, now I see it. So this line here will come here, and then this line here will come here. Obviously, they are going to complete. They are going to complete the what? The triangle. They are going to complete the triangle, those lines. So this line here is parallel to this line. And then this one here with 3, 1, 2, 3 is parallel to this one. 1, 2, 3. Then they form a triangle. Now my triangle looks very abnormal. But this is OL, then we're gonna have what? M there. All right. And then now OM, don't forget OM comes down here. OM. And then the parallel again of this will be drawn, and the parallel of that will be drawn. Then you have your T. So this one is parallel to that. This one is parallel to that. That's where you're gonna find your shear stresses on each leg. So leg 1, leg 2, and then the shear stress on the leg, I mean the stress on the leg or the force on the leg will be, or the shear leg is AO. Where's AO is the one with 2 ticks, which is this line MN. So MN will be the times scale to produce the force on the shear leg. MT times scale on one leg, and then OT times scale is the force on the second leg. That's how you do. The only thing is that it pushes further away for the shear for the shear leg. But you also have another one. Actually, that's a backstay. This one is a backstay. So I'm busy saying shear leg, shear leg, shear leg. It's a backstay. So when you have got a backstay, this line here is a backstay. Oh, sorry for my handwriting. All right, so this is the force on the backstay. We call it a backstay, not shear leg. Now, here's a shear leg with an overhang. So we are looking at this. If we draw it differently again. I'm just gonna draw it differently again. Let's try to see what can we do with this one. If you get something like this, the vector diagrams, we will do the same thing. So labeling, I'm gonna label it the way I want to label it, so that we can save time. So number 1, let's find the triangle, or let's get the data. There's a backstay 15 meters long. So PS backstay 15 meters, and 2 legs 12 meters long. Leg 12 meters. Remember, there are 2 of them. Let me not say multiply by 2. There are 2 of these legs. Okay, let's say by 2. And are placed. The legs are placed 12 meters apart. So the legs are 12 meters apart. We are going to see that. And apart, and the apex of the shear leg overhangs the hinges by the hinges of the legs by 6. So there's an overhang. Yes, 6 meters. And the legs are, let me just write apart. So they are apart by what? 12 meters. Now the scale is 1:3. So let's divide everything by 3. This one will be 5 centimeters. Divide these legs by 3. It will be, let me use black, 5 centimeters. Then divide this by 3. It will also be 4 centimeters. 12 by 3 here. The overhang will be 2 centimeters and 4 centimeters there. All right. Now let's see how we draw this one if it has got an overhang. So here the keyword overhang. Right. Now, how are we going to do this one? The legs are how many meters apart? Let's start with that, because this is where there is a good way of starting. The legs are 6 meters apart, or 2 centimeters apart. So remember, when we draw the legs, we draw the leg here and the leg there. So we are told that they are 2 meters apart, meaning that this is going to be your 2 meters to show that the, pardon me guys, apart 4 centimeters apart, meaning from there to there is 2 meters and 2 meters to produce the 4, of which the legs are apart by 4. Okay, so it's 4. So this is our more like our triangle, but they're giving us in a different way. Let's call this B. Let's call that A or BC, if you like. Let's call it BC. So it's 4 meters. So you start by drawing this. From there to there is 2, and from there to there is 2, because we must draw it like that. All right. And then see. And then from there, all right. And then from there, now the legs are how long are the legs? The leg are 4 centimeters because they are 12. 12 divided by 3 is 4, 8, 12. Yes. So we've got 4 centimeters, 4 centimeters. So these are the legs. They're going to give us the 0.01. 4 centimeters and 4 centimeters. All right. Let's continue. So when you are drawing, and then now there's this overhang thing of 2 centimeters. Now the overhang is from here to inside here, but by how much? By 2 centimeters. So you measure 2 centimeters, you make a point, and then you draw in the lines like this. So this is the overhang, 2 centimeters here. Highlighted in red, that's our overhang distance, 2 centimeters. Now, if you can realize, we don't have that point there of point A. We don't have it. But we are done drawing the legs. Okay, so what are we going to do now? We start projecting upwards. Let's project upwards. There's our B1. There's our O1. And then when we have this, you know what to do, an arc. Oops. Okay, let's try again. There's the arc like that. Okay, you'll draw a better arc with this being the center. Ne? Now, you then project upwards that overhang where the overhang ends. You project that one upwards like that, and there, when it touches the arc, that is the point original O. You remember? Original O. Now, from O, you know that the backstay joins from here or anywhere on this line to O, but now you are not drawing it from here to O, but you're drawing it from O down. So you measure 15, which is how much? 5 centimeters from here. So 5 centimeters from O, you draw it like that. It must be 5 centimeters. So where you get that, that means that is where your point A is going to be, which means this is your A1. Now you know what to do when you get there. You just simply join this one here. And then remember the load is facing down. I don't know what color I'm going to use for the load now. Let me use purple. There's my load, purple there, my load. Then you are done. The rest is now you have to do what you are told. The load is 20 kilonewton, and then the scale for the load is 10. So you divide 20 by 10, you get 2 centimeters, meaning OL must be 2 centimeters straight down. Then from there, parallel lines. But what I like to do is to make a dummy. In other words, this AO line, I'm going to make a dummy of that OM line here. It's parallel, these lines, né? Which means they give me this triangle here. That's where my OM is going to be. Which means now, all I need to do is to take this thing out and draw it according to scale here. So it's 2 centimeters, and then I need to draw that line there, which is going to be parallel to that. It's going to go like that. But now I need to make sure that this line and that line are parallel. And then remember, I'm going to have that line again of three dots. I'm going to draw it like that. 1, 2, 3. And then that's my O, L, and M. Don't forget, you go back with OM. And then BO, BO and OC are going to give me the value of T when I draw them in parallel. And then now you know, guys. Now you know again what you need to do. You know what you need to do again here. What you have to do. This one gives us this. This one gives us that force. I mean, this force here gives us the actual force on this leg. And this force here gives us the actual force on this leg. And then our backstay, which is also, you need to also find the in each leg as well as in the backstay. So where's the backstay? The backstay is this one here, which is parallel to this one, LM. So the value of LM is the backstays times scale. It's gonna give me the backstay. Even here, I multiply this length by scale, multiply this length by scale. That's how I work out these values, guys. I'm hoping the video not to be long, but it is now very long. Now here's a problem. This one is a serious problem. Not serious problem as in like yeah, it's gonna require a lot of work. But maybe we should meet and do this one in class, because this one will need us to do a lot. I can't show you how it's done here. So as soon as you practice these ones and then you understand them, then I think we'll just do this one in class. Maybe we'll do this one in class as well as the direct crane. Then I'm gonna make other videos because this one is very difficult to explain. Very, very difficult to explain. We'll only do it in class. So let me just pause it here.